Hello children, in this video we are going to learn chapter 4 electricity. You have already learned about electricity in your lower classes. Electricity deals with the flow of electric charges through a conductor. In this lesson, you will learn various terms used in understanding the concept of electricity. The use of electric current in our day-to-day life is very important and indispensable. You are already aware of that electric current is used in educational institutions, hospitals, industries, etc. What is electric current? It is defined as the rate of flow of negative charges of the conductor. In other words, the continuous flow of electrons in an electric circuit is called an electric current. The conducting material consists of a large number of free electrons which move from one atom to other at random. The flow of air from a region of high pressure to a region of lower pressure. In a similar manner, the current also passes from high electric potential to low electric potential, that is, positive terminal to negative terminal. Positive terminal has higher electric potential and negative has lower electric potential. So, current always passes from positive to negative. Electric current is represented by the symbol I. It is defined as the rate of flow of charges in a conductor. This means that the electric current represents the amount of charges flowing in any cross section of a conductor in unit time. If a net charge Q passes through any cross section of a conductor in unit time T, then the current flowing through metal is mathematically expressed as I equal to Q by T. Here, I equal to electric current, Q equal to net charge, T equal to time. The SI unit of electric current. The SI unit of electric current is ampere, represented by symbol A. The current flowing through a conductor is said to be 1 ampere when a charge of 1 coulomb flows across any cross section of a conductor in 1 second. We know that I equal to Q by T is the mathematical expression for electric current. Hence, 1 ampere equal to 1 coulomb by 1 second. 1 ampere equal to 1 coulomb by 1 second. We know that the mathematical expression for electric current is I equal to Q by T. Simply we can explain, for I, the SI unit is ampere. 1 ampere equal to Q, net charge, expressed in coulomb, that is 1 coulomb, by time. For time unit is second, that is 1 second. Therefore, 1 ampere equal to 1 coulomb by 1 second. Next, electric circuit. An electric circuit is a closed conducting path which has a network of electrical components through which electrons are able to flow. This path is made using electrical wires so as to connect an electric appliance to a source of electric charges. A schematic diagram of an electric circuit comprising of a battery, an electric bulb and a switch is given in this figure. This is simple closed electric circuit. If any disconnection happens, the flow of charges will stop and the bulb will not glow. For any appliances or bulb, if want to work, the circuit should be closed. Next, we are going to learn what are the components used in circuit and what is its use and what is the symbol used for particular component. This is resistor, used to fix the magnitude of the current. This is the symbol used for resistor. Already I said it is used to fix the magnitude of current through a circuit. Simply, a resistor can reduce current flow. Resistor can adjust signal levels. Resistors are used to divide voltages. Next component, rheostat, otherwise variable resistor. It is used to select the magnitude of the current through a circuit. This is the symbol used for rheostat. Next component, ammeter. This is the symbol used for ammeter. Ammeter is used to measure the current. We know that current is measured in the unit ampere. Hence, it is named as ammeter. This is voltmeter. It is used to measure the potential difference between 2 points in an electric circuit. Simply, voltmeter is used to measure the voltage. For example, if our car is not start, we can measure the battery voltage by voltmeter, and we can decide whether the battery of car is charged or drained. This is symbol used for voltmeter. This is galvanometer. This is used to indicate the direction of flow of electric current. This is symbol used for galvanometer. Next component, diode. A diode has various uses. It can be used as a rectifier, signal limiter, voltage regulator, switches, signal modulator, signal mixture, demodulator, and oscillator. Detailedly, you will study about diode in your higher classes. This is symbol used for diode. Next component, LED, light emitting diode. It also has various uses. We will see later. This is symbol used for LED. This is symbol used for ground connection. It refers to a connection to the earth which acts as a reservoir of charge. A ground wire provides a conducting path to the earth which is independent of the normal current carrying path in an electric appliances. This protects against electric shock, and it is used to provide protection to the electrical component, also serve as a reference point to measure the electric potential. What is electric potential? An electric potential is the amount of work needed to move a unit of charge from a reference point to a specific point inside the field without acceleration. What is electric potential difference? It is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. Let us consider 2 points in electric field A and B. Q is the charge. Suppose if we moved a charge Q from a point A to another point B, let W be the work done to move the charge from A to B. Then the potential difference between the point A and B is given by the expression V equal to W by Q. That is, potential difference equal to work done by Q. It is also equal to the difference in the electric potential of 2 points A and B. VA is the electric potential of point A. VB is the electric potential of point B. Then the potential difference between point A and B is given by two-way. If electric potential at point A is more than electric potential at point B, then potential difference equal to VA minus VB. Similarly, if VB is more than VA, then potential difference, that is V equal to VB minus VA. The SI unit of electric potential or potential difference is volt. The potential difference between 2 points is 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to another, then 1 volt equal to 1 joule by 1 coulomb. Potential difference equal to work done by charge. Potential difference expressed in volt, work done expressed in joule, and charge expressed in coulomb. What is Ohm's law? A German scientist, Georg Simon Ohm, established the relation between the potential difference and current, which is known as Ohm's law. This relation can be understood from this. According to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between two ends of the conductor. That means the electric current I is directly proportional to the charge flowing between the point X and Y, that is V. I is directly proportional to V. Hence, I by V equal to constant. The value of this constant is found to be 1 by R. Therefore, I equal to 1 by R into V. Here R is nothing but resistance. What is resistance? It is the property to oppose the flow of charge. The flow of charge is current. The oppose the flow of charge is resistance. I is always inversely proportional to R. V equal to IR. That is, potential difference is the product of current and resistance. Here R is constant at a given temperature, since the potential difference V is proportional to current I. If we plot the graph between potential difference V and current I, we can get a straight line for the conductor. This is the relation between potential difference and current explained by Ohm's law. What is electrical resistivity? It is nothing but the measure of resisting power of material. What do you mean by resisting power? Resisting power is to oppose the flow of charges. Resistance means it just stops the passage of electrons through the circuit. Now we are going to derive mathematical expression for electrical resistivity. R is directly proportional to L. If length of wire increases, resistance also increases. This can be explained by experiment. Take two bulbs. One is connected with small length of wire, another with larger length. The bulb with small length of wire will glow brighter than another bulb which is connected with more length of wire. This explains that resistance is directly proportional to length of wire. R is inversely proportional to area of cross section. Now combine equation 1 and 2, we can get R directly proportional to L, inversely proportional to A. That is, R equal to rho into L by A. Rho is a constant called as electrical resistivity. If length equal to 1 meter, area equal to 1 meter square, rho equal to R. Its unit is ohm meter. Nichrome is a conductor with the highest resistivity equal to 1.5 into 10 power minus 6 ohm meter. The resistivity of some material are listed in our textbook. Conductor. The material are copper, nickel, chromium are given. For insulator, glass and rubber are given. For copper, the resistivity is 1.62 in 10 power minus 8 ohm meter. For glass, the resistivity is 10 power 10 to 10 power 14 ohm meter. Conductance of a material is the property of a material to aid the flow of charges and hence the passage of current in it. It is just opposite to resistance. Resistance is the property to oppose the flow of electric current. Conductance is the property to aid the flow of current in it. Now we are going to derive mathematical expression for conductivity. The conductance G is inversely proportional to resistant R. Thus G equal to 1 by R. The unit of conductance is ohm inverse. also represented as mho. The electrical conductivity is reciprocal of electrical resistivity. Thus, sigma equal to 1 by rho. Here, rho is electrical resistivity, sigma is electrical conductivity. The conductivity unit is ohm inverse meter inverse.